Here we are, section 14, putting it all together in some synthesis strategies. So there are two things to watch out for. First is always functional group conversions, and the second thing is carbon-carbon bond forming reactions. Now oftentimes we focus so much on an individual reaction and memorizing it with a flashcard, but we need to look at the overall picture, and these are sometimes called synthesis maps or atlases of interconversions. So, look at the boxes here. These kind of represent airports, and there's many different ways to get into them. How do you make a nitrile? This can come from a alkyl halide as well, right? So, there's this map is not complete, but you could add to it. How do we make an alcohol? From an aldehyde, from a ketone, stuff like that, right? So this is not shown, it's on the map, but how do we go from here to here? Well, you add sodium borohydride or LAH, right? So there's some lacking details here, but this gets you started on things, okay? So, construct your own map and draw different things into it. This is a diagram kind of left to right. It's less of a spider web diagram, so to speak, I like to call them. But here you can see the least reactive substances on the right and the most reactive substances on the left. So of course we're going from left to right, in these reactions. But these are how you convert the different carboxylic acid derivatives. Now the best way to just lecture on this is probably just to jump in with some problems, okay? So, well, first of all, let's talk about this carbon-carbon bond forming reactions. Here, Grignards, organolithiums, and Gilman reagents are all used to construct carbon-carbon bonds, okay? Sometimes you're adding only one, sometimes you're adding two alkyl groups, okay? Don't forget that cyanide has a carbon, and this is technically a carbon-carbon bond forming reaction to form, nitriles or carboxylic acids, okay? So let's jump into some practice problems here and just get to work. So I'm looking at problem 32 in the book. Okay, so here's a problem where we're just simply doing a functional group manipulation. We're not making carbon-carbon bonds. So here we are at the ester stage. Okay, and we want to make an acid chloride. All right, so we want to go from here to here. Okay, so how do we do that? Well, what I would have put on this diagram is that carboxylic acids can be converted to acid chlorides with thionyl chloride. Okay, but anyways, the way to go from an ester to a carboxylic acid is through hydrolysis. So what I would do for this is I would add, water and acid to make the carboxylic acid, and then I would add thionyl chloride. Okay? Let's try to do another one of these. Okay, so here's part B from number 32. So it's 2132B. And we're going from a carboxylic acid. That's right here, okay? And we want to convert that to a primary amine, which is way down here. So think about the path that we would need to do for that, okay? How do we do that? Gosh. So we need to think about all the arrows coming in and out of these things, okay? So basically, we need to maybe go this route, okay, to form the acid chloride, all right? And then we need to get the nitrogen in there, right? So we could use excess amine. Okay, so that's going to get us to the amide. And then we could use LAH and water to give us the primary amine. And when you look at all these arrows, you don't see any other pathway to that really necessarily. So that's what I would do for the reactions. So step one, I would add thionyl chloride. Step two, I would add excess ammonia. And step 3, I would add lithium aluminum hydride. And of course, there's that water workup kind of thing for the LAH. Okay? So be familiar with the maps. Let's do another problem. Here we are back in 2132 part C, and we're starting from an acid anhydride. So that's right here, okay? And we want to make an acid chloride, okay, which is over here. And we need to think about how to do the conversions. So one way to do this problem would be to take our anhydride, treat it with water, and that would form the carboxylic acid here, and then we could treat that with thionyl chloride to form the acid chloride. So let's write down that proposal here. Step 1, we're going to add water. Step 2, thionyl chloride. So once again, please familiarize yourself with the this map, okay? Let's do another problem. 2132 part D, we're starting with an ester right here. So the R group is an ethyl group. And we want to synthesize a primary amine, which is down here, okay? So this kind of looks more straightforward because you've got a kind of a left to right situation. So if we take our ester and treat it with ammonia, okay, we can get to this amide. And then if we treat that with lithium aluminum hydride, then water, we can get to our amine. So that's something we could propose here. So step 1, we're going to add ammonia. Step 2, we're going to add LAH. Okay. And step 3, we're going to add water. Okay. So we're just using the map to kind of solve these things. You want this ingrained in your mind. So when you fall asleep, you can't stop thinking about this before you go to bed at night. Let's do another problem. Okay, we've got part E. We've got a carboxylic acid. Let's see, that's right here, top center. And we want to convert that to a nitro, which is a different carboxylic acid derivative. So we don't have a whole lot of arrows going into this. How do we do that? How do we do that? Well, there's lots of different ways you could think of doing that. Basically, you can think backwards, okay? So let me change this highlighter to purple. We can make an amide, okay? Amides can be converted to the corresponding nitriles. In this case, I'm starting with a carboxylic acid, so I'm going to choose to make a acid chloride, which then can be reacted with excess ammonia to form the amide. Could you do this a different way? Yes. Yes, you can, right? There's many different ways of doing this. So what I would propose for my answer here is first treat this with thionyl chloride. That makes the acid chloride. Treat this with excess ammonia. That makes the primary amide. Then treat this with thionyl chloride once again. And that will make the nitrile, okay? I think you got the hang of this. Problem 32 has parts all the way to J. On the next page, it says try problems 2145A and B, 2146A, 2152, 2153A, and so on and so on and so on. Please check the playlist that this video is currently in on YouTube, and there will be lots of other practice problems there, okay? Let's do another practice problem from the book. 2135, Part A. And what we have here is a situation where we have a new carbon-carbon bond, okay? We're stitching together these two carbons. We're putting in an ethyl group, okay? And this is an alcohol here, okay? An alcohol. Now, we don't have that. You see, this is an alcohol, but it has two R groups, so we don't want to use that. This has one R group, okay? And this has one R group. So either of these methods can be used. Now, this reaction right here would be quite nice to give us a reaction useful and related to this problem. So what I would do is I would convert this to an acid chloride. Okay, we can do that by treating this with thionyl chloride. All right. And then I can treat this with an appropriate Gilman reagent. Okay, so R would be ethyl in this, so we're just replacing that red R here with the ethyl. Okay, and that will make a ketone. Okay, and then here's where, I mean, it's kind of cumulative. This comes from the ketone chapter. If you treat this with, say, for example, sodium borohydride in the solvent known as methanol, you can get the alcohol. Okay. So what are the key steps here? The key step is knowing that you're going to have to convert this to an acid chloride. Okay. And another key step is you knowing that you're going to have to use the Gilman reagent to convert that to the ketone. Okay, so that's the key carbon-carbon bond forming step in this problem. Let's do another couple problems and see what we come up with. Okay, part B, we've got this alkyl halide, and we're making a new carbon-carbon bond. A new carbon. Well. This bromine, right, we're changing it to a carbon here. So there's a carbon and there's a carbon. So this is the new key carbon-carbon bond that we're trying to form, okay? And then you've got this this weird-looking group attached to that, okay? So how are we going to do this this problem? Now, before I jump in, I just want to mention that this right here is an alcohol, okay? This right here is the alcohol part of an ester. And this right here is the acetyl group. Remember we talked about making aspirin and Tylenol? We can acetylate alcohols, okay, to make acetate esters. So how are you going to make an alcohol with one additional carbon? Okay, well, we can use this synthesis here to get the one additional carbon and then convert that by reduction to an alcohol. Okay, so let's sketch out what I mean here. If we have bromobenzene, we can treat that with magnesium. This works with all alkyl halides. You add carbon dioxide, acid workup, and that's going to form benzoic acid. Okay, kind of a boring molecule to talk about right now, but we have the carbon-carbon bond. Okay, so there it is. We have one additional carbon atom. Now, if I treat this with lithium aluminum hydride and water, remember that carboxylic acids can be converted to alcohols. Okay, so there's my alcohol. All right, now what I need to do is to treat this with acetyl chloride, for example, in pyridine, and that will stick on an acetyl group or an acetate. That's called an acetylation. Okay, so now we have an acetylated alcohol. That's the correct product. Okay, so we put on the acetate group. Okay, pretty challenging problem. Let's do the third problem in this problem. Now, let's look carefully as to what is going on here, okay? So we have a carbon right here, okay? And we're installing two new groups, okay? A methyl group and a methyl group. So we're forming two groups. And when I look at this molecule, I can see that that's a way we could add two groups, okay? And we form an alcohol, right? So the alcohol portion could be the left-hand side of this molecule, okay? And then we can do an acetylation as before, realizing that this can come from acetic anhydride or acetyl chloride or something like that. Okay, so that's my acetate group. Okay, so just remember, esters come from alcohols and say acid chlorides. Okay, so how do we make the alcohol? That's the hard part of this problem. Okay, now we don't have this. We don't have an acid chloride or an ester or something like that. We have a nitrile. Okay, so you know what do we do there? How do we do this? Now we could go this route because you can add another R group by just reacting the ketone with a new Grignard. Okay, and that will form an alcohol, you know, with your two R groups. Okay, so let's do that to do something different or new. Okay, so my proposal would be to take benzonitrile okay, and react it with methyl magnesium bromide, add acid to hydrolyze that intermediate amine, and then you're going to make the acetophenone, right? Acetophenone. And ketones, remember, they can react with Grignards. To give you alcohols, okay, tertiary alcohols. Now that I have my tertiary alcohol, like in the previous problem, I could react this with acetyl chloride and pyridine. Okay, and that will give me my ester. All right, there's only 3 problems here in problem 35. And there's other ones here, and they propose doing problems 45B, 25, 53, BD, 54, 55, 58, 74. So check the playlist for more problems. But basically, all I want to say in this video is that you really want to be extremely familiar with carbon-carbon bond formation and this reaction map. Okay? Thanks for watching. Good luck.